Good afternoon, dear ladies and gentlemen. My name is Norbert Mayr, and I'm one of the heads of Tyrrell and Mayr Civil Engineers in Austria. The other head is sitting in front of you. Today I will tell you some hopefully interesting things before the coffee break about the project we are part of in designing and inspecting for almost 10 years now. In 2002, a flood event in upper and lower Austria shocked the country. Many valleys in the foothills of the Alps that had been regarded as safe from submergence were flooded, and the economic damage was high since these valleys are very densely populated. One of these valleys is the river Krems in Upper Austria, where the river had been regulated in the 1960s. After the flood, the research for the reasons of the disaster was started and concepts were created. For the upper regions of the valley, a basin for flood detention was concepted. This is the reservoir Krems-Au, which I want to tell you about. One focus of my presentation is the hydrological dimensioning of the reservoir. The other one, aspects of safety and the construction of the Austrian Dam Commission. And at the end of my presentation, you will see some photos of the building phase. I have already told you about the problems we have in these mountainous regions. The stream regulation measures of the 20th century appear as much too small. The floods in 2002 and partly also in 2013 have shown this. The challenges are to plan and to build reservoirs for the mitigation of floods with dimensioning the necessary volume. The other challenges is to the construction that has to be safe up to very rare floods because of the dense population and industrialization in connection with the danger of flood waves that threaten human lives. Here you see some photos of the flood of 2002. This is the city of Krems-Münster. Here you see a picture of A1 motorway, one of the most important motorways in Austria that was flooded by the Krems. Here another picture of Krems-Münster and settlement part of the city of Ansfelden. A short geographic overview on this slide. You see part of Upper Austria with the Alps in the south, where the river Krems has its sources. Here you see the Krems River in light blue. The Krems flows here into the river Traun and on into the Danube. Here is the capital of Upper Austria, the city of Linz. Here you see a map of the Krems with several measures to mitigate floods, most of them detention basins, and one of them in the south here. This is our detention basin, Krems-Au. Since 125 years, there is a governmental institute in Upper Austria that surveys all kinds of hydrographical data. In the catchment of the Krems, which is about 400 square kilometers, we have 4 water gauges and 4 rain gauges. And on this picture you see a series of the highest runoff of each year since 1895 of the water gauge of Krems-Münster with the highest peak in 2002. The hydrological calculation of extreme flood peaks is based on statistical methods here, and they were calculated by the Hydrographic Agency of Upper Austria. On this chart you see the results of extreme value distribution with expected value and rated value on a confidential interval of 80% on the right. For the gauge of Krems-Münster, one of the oldest water gauges in Upper Austria with a catchment of 147 square kilometers. The volume of the reservoir was calculated by rainfall runoff modeling. The model could be calibrated on behalf of the flood of the 12th of August 2002. The dimensioning of the volume was made for a 100-year flood, which is the usual annuality for flood management in Austria. The volume that resulted in the end of that process was 2.6 million cubic meters. On the chart you can also see the calculated hydrograph of the disastrous flood in 2002. For the safety construction of the dam, the Austrian Commission on Dams, ACD, requires to calculate a so-called design runoff with an annuality of 5,000 and a safety flood with an annuality of 10,000. This calculation has to be made on a so-called multi-pillar approach. The runoff must be calculated by 4 different methods, and the results have to be discussed. In this case, we took the local frequency analysis of the water gauges Krems-Münster and so on, a completely statistical method, further regional flood frequency analysis, which is a statistical method in general too, further rainfall runoff modeling, and the Gradex method. Here you see the results of the multi-pillar approach with a design flood of 240 cubic meters per second, nearly the double of the 100-year flood. So we come to another main chapter of my presentation, the construction of the dam and safety aspects. Here you see the dam with a length of 1,870 meters on the right side, on the east side, and with a height of maximum 9 meters here in the north. The dam itself will have a volume of 360,000 cubic meters. You can also see the flooded area inside the reservoir with an area of 1 square kilometers and a volume of water of 2.6 million cubic meters. On this plan you can see the typical stratigraphic sequence of the soil in the Krems Valley. There is a cohesive and mostly soft covering layer with a thickness of 1 up to 2 meters. Under that we find 3 to 4 meters of gravel with slightly confined groundwater, and the aqueduct is built of marl in a depth of about 6 meters. The dam itself consists of an impervious dam core in the center, an upstream body made of silt covered by gravel on the upstream side, and at the downstream body consists of a sandwich construction made of silt and gravel. To prevent undercurrent of the dam through the pervious gravel layer, we constructed an underflow barrier here by soil stabilization. The volume of each body is about 120,000 cubic meters. Almost all materials you see here can be won inside or very near the reservoir, so transport costs can be minimized. On this slide you see the main scour outlet. It is designed to reduce runoff from up to 130 cubic meters to a maximum of 60 cubic meters per second. The reduction is made by two sluices you see here on the left side, each one with an area of 12 square meters. These sluices are normally open and will be closed when the water level in the nearest settlement reaches a certain critical value. The outlet is exposed to daylight on most of the length of 72 meters, especially for insects and birds that fly along the water level and also for water organisms. The height of the outlet from the foundation to the top is 13 meters. The spillway for extreme floods, which fill the reservoir above its capacity, is designed as a rough ramp with a slope of 1 to 5. The specific runoff is 1.5 cubic meters per second and per meter. For these geometric and hydraulic conditions, a simulation test had been run at the University of Vienna for a similar case some years ago, and we used that for this spillway. On the top, we designed a wall of rounded concrete to reach a high wear coefficient, and on the slope we have two layers of breakwater stones, 800 to 1,000 kilograms, that have to be laid very roughly to conserve the energy on the slope and not at the bottom. So the stilling basin here could be designed very short, just a few meters. Dams for water supply, flood mitigation, and irrigation reach back in Austria to the times of the Romans. In Austria, the building of larger dams now for energy production started at the beginning of the 20th century. In 1916, a failure of a flood mitigation dam called Weiße Tesse caused many victims and led to fundamental guidelines in 1917, in the middle of the First World War, and to the foundation of the Austrian Dam Commission in 1918. The ACD consists of a panel of experts of all fields of dam engineering, and following the Austrian water law, it has to be consulted in cases of projects with a height above 15 meters or with a reservoir capacity more than 500,000 cubic meters. The ACD is administered by the Federal Ministry of Sustainability and Tourism. It has examined since 1918 about 150 dams. Now, the authorization procedure starts by appointing a panel of a few experts of the ACD for certain important fields as geology, hydrology and hydraulics, dam design, analysis, and mechanical engineering. Their expertise is discussed in a meeting of the plenum of the ACD, and the final expertise is the basis for the stipulations of the authorization. Special discussions on the dam of Krems-Au were at first the building of a very heavy dam on a very bad ground of soft clay that cannot be changed to insensitive layers. Second, it was if and how excess pore water pressure can be avoided by very slow emplacement of the dam in thin layers. And third, avoiding groundswell by soil stabilization. Now, at last, some pictures. We are now ready with phase one of the construction. Phase one included the main scour outlet you see on this picture. It included river works and a new bed for the river Krems inside the basin. Then we built a new water power plant and some sewer lines and so on. On this picture you see the main scour outlet where the dam will be fitted to on both sides from this year to 2021. In the middle you can see the center of the dam with inclined walls for higher compaction and spurs of concrete to prevent streaming along the walls here. Another picture of the scour outlet from downstream. In the center you see the two sluices with 12 square meters each that will be installed, and the whole construction will be passable for fish and other water organisms. The last picture is the new bed for the Krems River inside the basin, just a few days after flooding the first time, which we are very proud of. I've told you some words about the timetable. The start of the conception was after the flood of 2002. The project for the Austria authorization procedure started in 2010 and lasted 4 years. Financing took 2 years of time until 2016. Now we have projected and tendered building phase 1 and building phase 2, which starts in 2019 in some weeks, and we hope to be ready for startup in 2021. Some financial aspects at the end. The construction costs were calculated in 2015. Now, after finishing phase 1 and after tendering phase 2, we are optimistic to hold the budget of 21 million euros. And the building owner is also optimistic to hold the engineering costs of 2 million euros. And together with the acquisition of land, which took 7 million euros, the total costs are 30 million euros. So I may thank you for your interest. The declaration statement is just visit us in Krems-Au if you like. We have a very interesting building there to see for you. Thank you.
Thank you.